Imagine waking up tomorrow and discovering that the skill you learned last month is now worth $300,000 a year. Not to a tech giant, not to a Fortune 500 company, to any business, anywhere in the world, that wants to survive the next 5 years. This is not a fantasy. This is what is happening right now. The AI revolution is not coming. It is already here. And while millions of people are watching it unfold on the news, a small, quiet group of individuals is learning the exact skills that will make them irreplaceable in a world where artificial intelligence changes everything. In this video, we are going to reveal the 3 AI skills that are already commanding salaries and freelance rates that would have seemed impossible just 3 years ago. We are going to show you what these skills actually are, why the demand for them is exploding, and exactly how you can begin learning them today, even if you have never touched a line of code in your life. Stay with us until the end, because the 3rd skill is the one almost nobody is talking about, and it might be the most valuable of all. Every generation has its defining moment. The moment when the rules of the economy shift so dramatically that those who adapt become wealthy, and those who resist get left behind. In the 1990s, the defining skill was knowing how to use the internet. The people who understood email, websites, and digital communication early built careers and companies that still dominate today. In the 2000s, it was mobile technology. In the 2010s, it was data and social media. Now, in the mid-2020s, we are living through a shift that experts are comparing not to the invention of the smartphone, but to the invention of electricity itself. Artificial intelligence is no longer a concept confined to science fiction or research labs. It is now embedded into businesses, hospitals, law firms, marketing agencies, logistics companies, and governments around the world. And every single one of these organizations needs people who understand how to work with AI, not just use it, but direct it, shape it, and deploy it in ways that create real value. Here is the truth that most people are missing. The biggest opportunity in this AI revolution is not in building the AI. The companies building the models, the OpenAIs, the Anthropics, the Googles, those jobs require advanced degrees in mathematics and computer science. Most people will never compete for those positions. The real opportunity is in applying AI, in knowing how to take these extraordinary tools and turn them into business results, products, and systems that actually work. That is what this video is about. The 3 skills that sit at the intersection of human intelligence and artificial intelligence, the skills that are creating a new class of high-income professionals, and that are available to anyone willing to learn them. Let us begin. Before we talk about the skills themselves, we need to understand the world we are stepping into. Because the numbers are staggering, and they tell a story that most people are not yet fully processing. According to research from McKinsey Global Institute, AI could add up to $13 trillion to the global economy by 2030. That is more than the entire GDP of China today. Goldman Sachs analysts have estimated that AI could automate tasks that represent the equivalent of 300 million full-time jobs globally. And the World Economic Forum has projected that while AI will displace millions of jobs, it will simultaneously create 97 million new roles that do not exist today. Now, here is what most people get wrong when they hear statistics like these. They assume this is a warning, a reason to be afraid, a sign that the future belongs to the machines. It is not. It is an invitation. Every time technology has disrupted the economy, and it has happened many times before, the people who fared worst were not those who lacked natural talent or intelligence. They were the people who were too slow to learn the language of the new era. And the people who fared best were those who positioned themselves at the intersection of the old world and the new. Right now, that intersection is AI. Consider what is happening in real time. Companies like Google, Microsoft, Amazon, and tens of thousands of smaller businesses are spending billions of dollars integrating AI into their operations. But here is the bottleneck they keep running into. They have the technology, but they do not have enough people who know how to use it strategically and skillfully. A survey conducted by IBM in 2024 found that 40% of the global workforce will need to reskill over the next 3 years because of AI. And companies are willing to pay premium salaries to people who arrive already skilled. LinkedIn's most recent workforce report identified AI-related skills as the fastest-growing category of job demand globally, not just in technology sectors, but in healthcare, finance, law, marketing, education, and manufacturing. The window to position yourself ahead of the curve is open right now. But windows like this do not stay open forever. So what are the 3 skills? Let us get into them. The first skill is one you have almost certainly heard of, but probably not in the way we are about to describe it. Prompt engineering. Now, before you roll your eyes or assume you already know what this is, stay with us. Because what most people call prompt engineering is a pale shadow of what the market is actually rewarding. Here is how most people think about prompts. You type a question into ChatGPT or Claude or Gemini, and you get an answer back. If the answer is not great, you rephrase the question. Simple. That is not prompt engineering. That is using a search engine with extra steps. Real prompt engineering, the kind that commands salaries between $80,000 and $300,000 annually, is about something much more sophisticated. It is about understanding the architecture of large language models deeply enough to consistently extract precise, reliable, high-quality outputs at scale in ways that create measurable business value. Let us break down what that actually means in practice. Imagine a law firm that wants to use AI to review contracts. A basic user might type, "Review this contract," and find any problems. An AI prompt engineer designs a system that breaks the contract review into structured phases, liability clauses, intellectual property terms, termination conditions, indemnification language, and creates a series of interconnected prompts that extract information from each phase in a consistent, reliable format that can be compared across thousands of contracts. The difference in output quality is not 10% better. It is orders of magnitude better. And the difference in business value is the difference between a tool that is occasionally useful and a system that replaces an entire department of junior associates. Prompt architecture, which is the advanced form of prompt engineering, involves designing multi-step AI workflows where different prompts feed into each other. You are essentially writing a program, but instead of code, the language is natural language. The instructions you give the AI determine the quality of every output it produces. Now let us talk about why this skill is worth so much. First, it is genuinely difficult to do well. Most people who attempt it give up because they do not understand why their prompts are producing inconsistent results. Learning to diagnose and fix prompt failures requires patience, systematic thinking, and a deep understanding of how these models process information. Second, the applications are infinite. Every industry, every function, every type of business can benefit from well-engineered AI prompts. A skilled prompt architect can work with a marketing agency on Monday, a hospital system on Wednesday, and a financial institution on Friday. The core skill transfers everywhere. Third, the results are immediately visible and measurable. When a prompt engineer improves a company's AI workflow, the impact shows up in hours saved, errors reduced, and revenue generated. This makes it easy to justify high compensation. So what does learning this skill actually look like? It starts with understanding the fundamentals. How do large language models work at a conceptual level? What is a token? What is temperature and why does it matter? What is the difference between a system prompt and a user prompt? These are not hard concepts, but most people skip them, and that is why their prompts are inconsistent. From there, you learn the core prompting techniques. Chain of thought prompting, where you guide the model to reason step by step before giving an answer. Few-shot prompting, where you provide examples that show the model exactly what kind of output you want. Role prompting, where you assign the AI a specific persona or expertise level that shapes its responses. Structured output prompting, where you design prompts that reliably return data in formats that can be processed by other systems. Then comes the advanced layer, prompt chaining, RAG architecture, that stands for Retrieval Augmented Generation, which allows AI systems to pull from specific knowledge bases before responding. Agent frameworks, where multiple AI models work together in sequence to complete complex tasks. The professionals earning the highest rates in this space are the ones who can take a complex business problem, design an AI workflow that solves it reliably, document it so that non-technical stakeholders can understand and approve it, and then deploy it in a way that integrates with the company's existing tools. One practical path to building this skill: start with free resources. Anthropic, OpenAI, and Google all publish detailed documentation on prompt engineering. Work through them systematically. Then practice by choosing a specific problem. It can be in your own life or your current job, and try to solve it entirely with AI prompts. Document what works and what does not. Build a portfolio of prompt systems you have designed. Within 6 months of focused practice, you can reach a level of competency that positions you above 90% of the market. And within a year, you are in the top tier. The demand is real. The skill is learnable. And the clock is ticking. Here is a layer to the prompt engineering story that most guides and courses completely ignore. The highest earning prompt engineers are not generalists. They are specialists. They are prompt engineers who also happen to know medicine or law or finance or real estate or logistics. Because in those industries, the ability to design AI systems that accurately handle domain-specific knowledge is worth far more than a general-purpose AI workflow. Think about it from a hospital administrator's perspective. You need an AI system that can help process patient intake forms, flag potential medication interactions, and generate preliminary clinical summaries for review by physicians. You could hire a talented but inexperienced prompt engineer who knows nothing about medicine, and you would spend months teaching them the clinical context before they could build anything useful. Or you could hire someone with a background in healthcare administration who has also deeply learned prompt engineering. They walk in on day one understanding HIPAA, medical terminology, clinical workflows, and the specific risk thresholds a hospital operates within. They can build a functional prototype in weeks instead of months. That person is not just a prompt engineer. They are a domain expert prompt engineer, and the market pays them like it. This is a crucial insight for anyone who currently works in a specialized field. Your existing expertise is not obsolete. It is leverage. The combination of deep domain knowledge plus AI skills is one of the most powerful professional combinations you can have in 2026. A nurse who learns prompt engineering does not have to compete with computer science graduates. She is operating in a completely different market, one with far less competition and far greater demand. If you currently work in any specialized field, accounting, architecture, engineering, education, law, medicine, agriculture, logistics, your fastest path to becoming highly valuable in the AI economy is not to abandon your expertise. It is to add AI skills on top of it. The second high-value AI skill is one that fewer people are talking about, but it may be the one with the highest short-term earning potential. AI systems design and automation architecture. Let us start with a simple question. What happens after a company decides they want to use AI? Most people assume the hard part is getting access to the AI. But access is easy now. ChatGPT, Claude, Gemini, Midjourney, and dozens of other AI tools are available to anyone with a credit card. The hard part, the part that creates enormous value, is building the systems that make AI useful inside a real organization. Because AI tools on their own are like raw materials. They have potential, but they do not produce results without structure, without integration, without the connective tissue that turns isolated AI capabilities into coherent, automated workflows that solve actual business problems. That is what AI systems designers build. Here is a concrete example to make this real. A mid-sized e-commerce company receives about 2,000 customer support messages every day. Before AI, they employed 15 customer service agents to respond to those messages manually. The average response time was 6 hours. Customer satisfaction scores were moderate. Agent burnout was high. An AI systems designer comes in and builds the following architecture. First, an intake system that automatically reads every incoming message and classifies it by type: shipping inquiry, return request, product question, billing issue, or complaint. Second, a routing system that sends simple, high-confidence queries directly to an AI responder that handles them automatically. Third, a secondary system that takes medium-complexity queries, drafts a response using AI, and routes it to a human agent for review before sending. Fourth, a priority escalation system that flags high-urgency messages, angry customers, legal threats, significant financial issues, for immediate human attention with full context automatically compiled. The result? The company handles the same volume of customer messages with 4 agents instead of 15. Response time drops from 6 hours to 4 minutes for automated messages. Customer satisfaction increases because responses are faster and more consistent. The 4 remaining agents spend their time on genuinely complex cases where human judgment adds real value. The AI systems designer who built this did not write a single line of novel code. They used existing tools, an AI language model for the responses, a no-code automation platform for the routing logic, and a CRM integration for the data connections. The skill was not programming. It was architecture, understanding how to design a system that solves a real problem, choosing the right tools for each component, and making them work together reliably. This is the skill, and it is extraordinarily valuable. Let us talk about the tools that make this possible, because this is another misconception we need to address. Many people assume that building AI systems requires advanced coding skills. It does not. At least not at the level required to create substantial value. Platforms like Make, formerly Integromat, Zapier, and N8N allow people to build sophisticated automation workflows visually, dragging and dropping components without writing code. These platforms now have native integrations with all major AI tools, which means you can build an AI-powered workflow that connects to your company's email, CRM, database, calendar, and communication tools with a few hours of work. For more complex architectures, tools like LangChain, LlamaIndex, and CrewAI allow you to build multi-agent AI systems, where different AI models collaborate on different parts of a task, with a relatively modest amount of Python coding. And if you are not a programmer, there are visual wrappers for these tools that make them accessible without deep technical knowledge. The highest value AI systems designers are those who combine 3 things. First, the ability to understand a business's operations deeply enough to identify where AI automation can create the most value. Second, the ability to design an architecture, on paper, before touching any tools, that solves the identified problem reliably. Third, the technical fluency to implement or oversee the implementation of that design using the right combination of AI tools and automation platforms. Now here is something important. The business understanding piece, step 1, is where most technically talented people fail. They fall in love with the technology and start building before they truly understand the problem. The AI systems designers who earn the most are those who spend equal time understanding the business as they do understanding the technology. How do you develop this skill? Start by learning one automation platform deeply. Make and Zapier are excellent starting points because they have extensive free tiers, large communities, and thousands of tutorials. Build 5 to 10 automation workflows that solve real problems. They can be personal projects, volunteer work for a local organization, or tools that improve your current job. Document each one. Understand not just what it does, but why you designed it the way you did. Then learn the basics of one AI language model API. OpenAI's API and Anthropic's API are well documented and designed to be accessible to non-programmers. Understanding how to make an API call, how to send information to an AI model programmatically and receive a response, unlocks an entirely new tier of automation capabilities. From there, learn how to connect these two worlds. An automation platform that can call an AI API and an AI API that can trigger actions in your automation platform is the foundation of almost every AI system being deployed in business today. Build a portfolio of 3 to 5 real automation systems. If possible, build them for actual businesses, even small local businesses, nonprofits, or organizations you are already connected to. Document the problem you solved, the architecture you designed, the tools you used, and the results you achieved. That portfolio is worth more than any certification. It shows prospective clients and employers that you can do the work, not just describe it. The market for AI automation designers is growing faster than the supply of qualified practitioners. Freelance rates for experienced AI automation architects range from $150 to $400 per hour. Full-time salaries at larger companies start at $90,000 and frequently exceed $200,000 for those with proven track records. And unlike some tech skills that require years of study to reach employment-level competency, a motivated learner can reach freelance viable skill in AI automation within 6 to 12 months of consistent practice. Let us bring this down to earth with a few real-world examples of how AI automation designers are creating value today. A small marketing agency in Austin, Texas, was spending roughly 30 hours a week creating performance reports for their clients. A junior employee would pull data from Google Analytics, Facebook ads, and several other platforms, paste it into a spreadsheet, write a narrative summary, and format everything into a branded PDF. It was tedious, time-consuming, and error-prone. An AI automation consultant built them a system in about 3 weeks. Every Monday morning, the system automatically pulls data from all connected platforms, passes it to an AI model with specific instructions about the agency's reporting standards and the client's goals, receives a formatted narrative analysis back, and assembles a branded PDF report, all without human involvement. The agency now delivers more insightful, more consistent reports to 15 clients simultaneously, and the employee who used to spend 30 hours on this task now spends that time on strategy and creative work. The consultant charged $12,000 for the project. The agency calculated they saved approximately $45,000 annually in labor costs, plus an improvement in client retention. The ROI was clear within months. A solo real estate agent in London was losing potential clients because she could not respond to inquiries quickly enough. Buyers and renters would contact her, not hear back for hours, and move on to competitors. An AI system designer helped her implement an intake system that automatically responds to all initial inquiries within 60 seconds, gathers the key information needed to assess the inquiry, qualifies whether it is a serious buyer or renter, and schedules a callback with her calendar, all automatically. Her lead conversion rate increased by 40%. She attributed 2 additional property sales in the first 3 months directly to the new system. The system cost her less than $2,000 to implement. These are not exceptional cases. They are representative of what is happening across industries at scale. And the people building these systems are in high demand, low supply, and very well compensated. We have arrived at the third skill. And as promised, this is the one that almost nobody is talking about, even though early practitioners are already earning extraordinary compensation. The skill is AI training, fine-tuning, and model behavior design. Let us start by clarifying what this is not. We are not talking about the foundational research that goes into building large language models from scratch. That work is done by a very small number of people with advanced academic credentials and is not accessible to most. What we are talking about is the practice of taking existing AI models and shaping their behavior to serve specific purposes. Teaching them to perform a specific task exceptionally well. Configuring them so that they respond in a particular voice, follow a particular set of rules, refuse certain types of requests, or demonstrate expertise in a particular domain. This is called fine-tuning and behavior design, and it is one of the fastest-growing disciplines in applied AI. Here is why it matters so much. The AI models that most people interact with are general purpose. They are designed to handle an enormous range of tasks reasonably well. But for most serious business applications, reasonable is not good enough. A hospital does not want an AI that can answer general medical questions. It wants an AI that reliably follows its specific clinical protocols, uses its preferred terminology, understands the specific electronic health record system it uses, and responds in a tone appropriate for patient communication. A financial services firm does not want an AI that can discuss finance broadly. It wants an AI that knows its specific product lineup, can accurately describe the regulatory constraints it operates under, understands its risk tolerance and investment philosophy, and consistently declines to give advice that falls outside its compliance guardrails. Building that level of specific, reliable AI behavior, and doing it in a way that actually works in production, not just in a demo, is the work of AI training and fine-tuning specialists. Let us walk through what this actually involves. The foundational technique is fine-tuning. Fine-tuning means taking a pre-trained model and training it further on a specific dataset, a collection of examples that demonstrate the kind of behavior you want. If you want an AI to write in a company's brand voice, you fine-tune it on examples of high-quality content written in that voice. If you want an AI to answer customer service questions in a particular way, you fine-tune it on thousands of examples of ideal customer service interactions. The technical barrier to fine-tuning has dropped dramatically in the past 2 years. OpenAI, Anthropic, and Google all offer fine-tuning APIs that allow practitioners to train customized versions of their models without building any infrastructure. The inputs are relatively straightforward: a set of training examples in a specific format, plus some configuration parameters. The outputs are a model that behaves differently, more specifically, more reliably than the base version. Beyond fine-tuning, there is a growing practice called constitutional AI design or model behavior architecture. This involves defining the rules, values, and priorities that govern how an AI system makes decisions when there are competing considerations. For example, imagine an AI assistant for a children's educational platform. You need it to be helpful, accurate, engaging, but also to maintain absolute age appropriateness in all content, to avoid any material that could be distressing, and to encourage children in specific pedagogically sound ways. Writing the rules that govern this behavior, in a way that the AI actually follows reliably, is a sophisticated design challenge. And getting it wrong has serious consequences. Companies are paying substantial amounts for people who can design, test, and refine these behavioral guidelines. Because the alternative, a deployed AI system that behaves unpredictably or inappropriately, creates legal liability, reputational damage, and in high-stakes applications like healthcare or finance, potentially dangerous consequences. There is also a growing field called AI evaluation and red teaming. As companies deploy AI systems, they need specialists who can systematically probe those systems for failure modes, scenarios where the AI behaves incorrectly, inconsistently, or in ways that violate intended guidelines. This is analogous to software quality assurance, but for AI behavior rather than code functionality. AI evaluators design comprehensive test suites that check whether an AI system performs as intended across a wide range of inputs, including edge cases, ambiguous scenarios, and adversarial inputs designed to expose vulnerabilities. They then analyze the results, identify patterns in failure modes, and work with prompt engineers and fine-tuning specialists to resolve the issues. This is a role that requires both technical understanding and careful, systematic thinking. It is not about programming in the traditional sense. It is about understanding how AI systems can go wrong and designing methodologies to catch and correct those failures before they reach users. How do you enter this field? The starting point is understanding the fundamentals of how AI models are trained. You do not need to build models from scratch, but you need to understand conceptually what training data is, why the quality and composition of training data matters, what overfitting and underfitting mean, and how fine-tuning differs from training from scratch. These concepts are available in accessible form through resources like Fast.ai, Coursera's AI specialization programs, and the documentation published by major AI companies. From there, practice fine-tuning models on real tasks. Start with small datasets and tasks that are easy to evaluate. If you want to fine-tune a model to write in a specific style, create a dataset of 100 to 500 examples, fine-tune a small model, and then carefully evaluate the results. What did it get right? What did it get wrong? Developing a rigorous methodology for evaluating AI outputs is as important as learning to fine-tune models. Many practitioners in this space have found that the evaluation work, designing tests, analyzing results, diagnosing failure modes, is where the most intellectual challenge and the most value is created. The market for fine-tuning and model behavior specialists is still forming, which means the practitioners who establish themselves now will have extraordinary leverage as the market matures. Companies are currently offering salaries ranging from $120,000 to $350,000 for experienced practitioners, with the higher end reserved for those who can demonstrate measurable improvements in AI system behavior for complex, high-stakes applications. This is the frontier. It is harder to enter than prompt engineering or automation design, but the compensation reflects that barrier. Now here is something that separates the people who build genuinely outstanding AI careers from those who achieve only modest success. The three skills we have discussed, prompt engineering, AI systems design, and model behavior design, are most powerful when they are combined. Think about it this way. A prompt engineer who does not understand systems architecture can write brilliant individual prompts but struggles to build workflows that are reliable at scale. A systems designer who does not understand prompt engineering produces automations with inconsistent AI behavior that erodes user trust. And a model behavior specialist who cannot design systems cannot deploy their fine-tuned models in ways that actually reach users. The professionals who are commanding the highest compensation, the $300,000 and above range, are almost always people who have meaningful competency in at least two of these three areas, and who understand all three well enough to collaborate fluidly across all of them. This does not mean you need to become an expert in all three before you start earning. It means you should think about your learning path as a progression. Start with the skill that aligns most naturally with your background. If you are analytical and systematic, start with AI systems design. If you are a writer or communicator, start with prompt engineering. If you have a technical or research background, start with model behavior design. Build genuine competency in that first skill, establish your first clients or employment, and then systematically expand into the adjacent skills. There is another layer to this convergence that is worth understanding. The most valuable AI practitioners are not just technically skilled. They are problem solvers who happen to use AI as their primary tool. The companies paying the highest rates are not looking for people who know AI for the sake of knowing AI. They are looking for people who can take a real business problem with all its complexity, politics, and constraints, and deliver a working AI-powered solution that makes a measurable difference. That requires business acumen, communication skills, and the ability to translate between the language of technology and the language of organizational decision-making. It requires understanding not just what AI can do, but what it should do in a specific context, and what risks need to be managed carefully. The practitioners who develop this full skill set, technical AI competency plus strategic business thinking plus strong communication, are extraordinarily rare and extraordinarily valuable. They are the ones who build the most impressive careers and create the most significant impact. Let us get practical. You have heard about the skills. Now let us talk about how you actually build them. The single biggest mistake people make when trying to learn AI skills is treating it like academic study. They sign up for courses, watch videos, read articles, and then wonder why they are not making progress. The reason is simple. AI skills are built through doing, not consuming. Here is a learning roadmap that works. Phase 1. Foundation, months 1 and 2. In the first 2 months, your goal is to develop a working understanding of how AI systems function and to get your hands dirty with the core tools. Start by reading the documentation of 2 or 3 major AI platforms. Read Anthropic's documentation on how Claude works. Read OpenAI's documentation on prompt engineering. These are free, well-written, and contain more practical insight than most paid courses. Do not just read, experiment as you read. Every time you encounter a concept, test it immediately. Set up accounts on the major AI platforms and get comfortable using their APIs, not just their chat interfaces. Understanding the API is what separates someone who uses AI from someone who builds with AI. Learn one automation platform to a functional level. Make, Zapier, or N8N are all good choices. Complete their official tutorials. Build 5 automations. They can be simple, but they should solve real problems that you actually care about. At the end of Phase 1, you should be able to write consistent, effective prompts for a variety of tasks, build simple automation workflows that integrate AI outputs and explain, clearly and without jargon, what large language models are, how they work at a conceptual level, and what they are and are not capable of. Phase 2, Specialization, months 3 through 6. In Phase 2, you choose your primary skill area and go deep. If you are focusing on prompt engineering, build a library of 100 prompt templates for a specific industry. Document the reasoning behind each one. Learn chain of thought, few shot, and structured output prompting techniques through intensive practice. Design and document 2 to 3 complex multi-step prompt systems that solve real business problems. If you are focusing on AI systems design, build 3 to 5 complete automation systems for real organizations. Even if you are volunteering your skills for a small business or nonprofit, real-world constraints are invaluable experience. Document each system thoroughly: the problem, the architecture, the tools, the implementation, and the measured results. If you are focusing on model behavior design, learn the fine-tuning process with a focus on data quality and evaluation methodology. Create and document a complete fine-tuning project from dataset creation through evaluation. Learn the fundamentals of AI evaluation and design a test suite for a specific AI application. Phase 3, Portfolio and Market Entry, months 6 through 12. In Phase 3, your goal is to translate your skills into income. Assemble a portfolio that documents your best work clearly and compellingly. A portfolio for an AI practitioner should include a description of each project, the specific problem you solved, the approach you took and why, the tools you used, and the measurable results you achieved. Use plain language. Assume your reader is a business decision maker, not a technical person. Then begin positioning yourself in the market. Create a profile on LinkedIn that highlights your AI specialization. Contribute to communities where your target clients or employers spend time: industry forums, professional associations, local business groups. Share insights and examples of your work. Build a small body of public content that demonstrates your expertise. Begin outreach. Identify 10 to 20 organizations that would benefit from your specific skill set. Write personalized outreach messages that reference a specific problem they have and briefly describe how you have solved similar problems for others. Be specific. Be humble. Focus on results, not credentials. The first client or employer engagement is always the hardest. After that, results speak for themselves, and referrals become your primary source of new opportunities. One more piece of advice that cannot be overstated: document everything you learn. Keep a journal or blog, even a private one, where you record what you tried, what worked, what did not, and what you learned. This habit accelerates your learning dramatically and gives you material for your portfolio and public communications. Before we close, there is something we want to say that goes beyond skills and salaries and learning paths. Because the people who will truly thrive in the AI era are not simply those who acquire the right technical knowledge. They are those who approach this era with the right mindset. The AI era rewards curiosity. The field is moving fast, faster than any previous technology wave. What was state-of-the-art in AI 6 months ago may already be superseded. The practitioners who succeed long-term are not those who learn the tools perfectly and then stopped. They are those who cultivate a genuine curiosity about where things are headed and a habit of continuous learning. This does not mean you need to keep up with every academic paper or every product announcement. It means maintaining a relationship with the field, reading regularly, experimenting regularly, and allowing your mental model of what AI can do to be updated by evidence rather than assumption. The AI era also rewards ethical clarity. As AI systems become more capable and more widespread, the decisions about how they are designed, deployed, and governed become increasingly consequential. The AI practitioners who earn the most trust, and therefore the most responsibility and compensation, are those who approach their work with a clear sense of the harms they want to avoid and the values they want to uphold. This is not an abstract philosophical point. It is a practical one. Organizations are increasingly asking their AI practitioners to make judgment calls about how systems should behave in ambiguous situations, whose interests the system should prioritize when they conflict, and what kinds of tasks the system should decline to perform. Having clear, thoughtful answers to these questions is a competitive advantage. Finally, the AI era rewards collaboration. Despite the narrative that AI is eliminating the need for human connection, the opposite is often true in practice. The most effective AI practitioners are those who work well with domain experts, executives, end users, and other technologists. They are skilled at listening, translating, and building the trust that allows organizations to take risks on new technology. AI skills open doors. Character and judgment determine how far you walk through them. Let us have an honest conversation about the cost of waiting. There is a very human tendency to delay action on things that feel large and uncertain. We tell ourselves we will start learning when things settle down, when the technology is more mature, when we have more time, when we feel more confident. But here is the truth about technology transitions. They never settle down. The AI field is not going to pause and wait for you to feel ready. And the cost of delay is not neutral, it compounds. Every month that you wait to develop AI skills is a month that someone else is building theirs. The practitioners who start now will have 12 to 24 months of experience by the time the mass wave of AI skill development reaches maturity. That experience gap is difficult to close. And in a market that rewards demonstrated track records, being early is a genuine advantage that cannot be replicated later. Consider the economics of it concretely. If you spend the next 12 months developing real competency in even one of the 3 skills we discussed, and you use that competency to add one high-paying client or earn a promotion or transition to a role that pays 30% more than your current position, the return on the time invested is extraordinary. And those outcomes are not hypothetical. They are happening for real people right now. The window is open. You are watching it from the right side. The only question is whether you will walk through it. Let us bring everything together. We are living through a once-in-a-generation economic transition. AI is not a trend. It is a fundamental restructuring of how work gets done and where value is created. And like every major transition before it, this one will create a new class of highly skilled, highly compensated professionals. People who position themselves at the intersection of human intelligence and artificial intelligence. The 3 skills we have discussed today, AI prompt engineering and prompt architecture, AI systems design and automation architecture, and AI training, fine-tuning, and model behavior design, are the skills that define that intersection right now. They are learnable. They are accessible to people without computer science degrees, without technical backgrounds, and without prior experience in AI. They are in demand across every industry and every geography. And they are worth pursuing with urgency and with seriousness. Here is what we want you to do right now. Before you close this video, decide on one concrete step you will take in the next 24 hours. It might be reading the documentation for one AI platform. It might be signing up for an automation tool and completing your first tutorial. It might be identifying the 3 organizations in your field that are most aggressively adopting AI and beginning to research how you might work with them. One step in the next 24 hours. That is the difference between watching this transformation happen and being part of it. If this video was useful to you, please share it with someone who would benefit from hearing this message. The more people who develop these skills and approach AI thoughtfully and ethically, the better this transition goes for everyone. Subscribe if you want to continue going deep on the skills and strategies that will matter most in the AI era. And leave a comment below telling us which of the 3 skills you are going to focus on first. We read everyone. The future belongs to those who prepare for it. And today, you took a step toward being one of them.